Hi viewers, in this video we will discuss about the differential equation, few past paper questions. So here we have the first question, uh, that is variable x and theta. The differential equation dx over d theta, 1 over 5 x plus 1 sine square 2 theta. So later on we will first we will separate, and once it is separate we will apply the integration and to find then we will find the constant. After that we will write this differential equation in form of f or x in terms of theta. So let's see the first step. Dx over d theta is equal to, here we can write x plus 5 over 5 sine square 2 theta, and then we will try to separate by taking x plus 5 over 5 other side. It is 1 over x plus 5 over 5 dx is equal to sine square 2 theta d theta, and then one more step, we can write 5 over x plus 5 dx sine square 2 theta d theta. Remember, now it's separate, so we can apply integration as well. But remember that the left hand side integration is very easy. We can apply a logarithm concept, but right hand side you must know few formulas like cos 2 theta equal 2 cos square theta minus 1, or it can be equal to 1 minus 2 sine square theta, or this formula of cos 2 theta can be equal cos square theta minus sine square theta, but I will use this one. From here it can be written as like that, 2 sine square theta equal 1 minus cos 2 theta, but remember we need double angle which is equal to theta. So for that, if you write sine square 2 theta, this becomes 1 minus cos 4 theta and divided by 2. So we will apply this same formula here, and it is integration 5 over x plus 5 dx is equal to 1 over 2 you can take outside, then write 1 minus cos 4 theta d theta. Now we can apply the integration. So it is 5 log of x plus 5 is equal to 1 over 2 theta minus the integration of cos theta is basically sine 4 theta divided by the derivative of 4 theta is 4. So as we are multiplying by 1 by 2, so it becomes 8, and plus constant of integration. So now we will find constant of integration c by applying the value of x is equal to 5 and theta is equal to, means that x is equal to 5 and theta is equal to 0. This becomes what? 5 log of 5 plus 5 10, and as theta is 0, so this becomes 0, and sine 0 0 as well, so it means c is equal to 5 log 10. So we will apply this value of c in the above equation. So it is 5 log of x plus 5 is equal to theta over 2 minus sine 4 theta over 8 plus 5 log 10. And as we are looking the differential equation uh, in expression x in terms of theta, so we have to find x. But before moving on that, we use few formulas of logarithm. So third law of logarithm says we can write the power as this value of 5 we can write in power, like log of x plus 5 whole power 5 is equal to theta over 2 minus sine 4 theta over 8, and this we can write also log 10 power 5, and if you bring it left side it becomes minus. So whenever there is a minus sign between logarithm, we can write in divide form, means x plus 5 over 10 whole power 5, and here we have theta over 2 minus sine 4 theta over 8. And next step, uh, by removing this log, we can bring exponential functions. So here we have x plus 5 over 10 whole power 5. And here right inside it becomes e power theta over 2 minus sine 4 theta over 8. And next step, we can take the power as 1 by 5 so that we can remove 5, like x plus 5 over 10 whole power 5 multiply 1 by 5, and right hand side e power theta over 2 minus sine 4 theta over 8. We can take whole power 1 by 5 as well here. So this can be cancelled and it is x plus 5. Take 10 other side, 10 e power. Apply this 1 over 5 with brackets as well, like theta over 2 multiply 1 by 5 gives me theta over 10 and sine 4 theta over 40. And next step, take 5 other side as we are looking x in terms of theta. So x is equal to 10 bracket open e power. I'm taking 1 over 10 as common as well. So it is theta minus sine 4 theta over 4 minus 5. So this is required uh, expression of x in terms of theta. I hope. Next question, the variable x and y satisfy the differential equation dy over dx x e power y minus x. So we have two functions, x and exponential. It means we can apply, once we separate, we can apply integration by parts. Later on, we will check the value of c, and then at the end we will write the expression in y in terms of x. So let's start with dy over dx x e power y minus x. So the first step is to separate this differential equation, and it is we can write e power y e power minus x. We can take e power y left side, so it becomes in divide form. So 1 over e power y dy is equal to x e power minus x dx, and then we can apply integration as well. But remember, right hand side there are two functions, so we can apply integration by parts. So this formula will work for us. Integration u dv is equal to uv minus integration v du. So here I will take x as first function, u is equal to x. That means du is equal to du over dx equal 1. That means du is equal to dx. And second integration dv, we will take the second function, which is integration minus x dx. So this becomes v equal e power minus x over minus 1. So now we can replace. So here we have integration e power minus y dy is equal to integration x e power minus x dx. So left hand side it is very easy, minus y over minus 1 is equal to right hand side we can use integration by parts concept. So my first function is u, which is x, here, and second v is equal minus e power minus x minus integration v is minus e power minus x dx. And next step we have minus e power minus y is equal to minus x e power minus x plus, but once you take integration of e power minus x, it gives me e power minus x over minus 1 plus constant of integration. So e power minus y is equal to minus x e power minus x minus e power minus x plus c. So now we will find the value of c by applying y is equal to 0, x is equal to 0. So if y is 0, that means e power 0, here 0 minus e power 0, it means minus 1 plus c, that means c is equal to 0. So if we replace back, this gives me minus e power minus y is equal to x e power minus x, this is minus, so, and then minus e power minus x, c is 0. Now our next step is to find uh, or to write y in terms of x. So before moving on that, I will do one step. We can take minus e power minus x as common. So it is x plus 1. Now cancel minus and minus and apply log on both side. Log of e power minus x and x plus 1. So once we apply log, that we can bring down the power, and log of e is 1. And right hand side, we can say that log of e power minus x bracket open x plus 1, or we can multiply minus both side. So it becomes y is equal to minus log of e power minus x bracket open x plus 1. So this is our required expression, which is y in terms of x. I hope so it is clear. Remember that this answer will help us to find the answer of B part. So after that, we will move on B. So in B part, find the value of y when x equal 1, giving your answer in the form of a minus ln of b, where a and b are integers. So remember that our first part answer was y is equal to minus log of e power minus x bracket open x plus 1. So now when x equal 1, this becomes what? So we will replace back y is equal to log of e power minus 1, 1 plus 1. So this gives me, I remember that there is minus sign as well. So minus log of e power minus 1 into 2. And remember that when you apply log on both function, you can write there is addition sign, like take minus as common. So log of e power minus 1 plus log of 2. And then next step, we can say that minus bracket open. So if you bring down minus 1 and log is 1 plus log 2, and next step it is 1 minus log 2. So this is the required form of a minus log of b. Next question, a balloon in the shape of sphere has a volume v and a radius r. Air is pumped into the balloon at constant rate. So it means rate of change with respect to t, our time, dv over dt is 40 pi. But remember that this is starting when t equals 0 and r is equal to 0. At the same time, air begins to flow out. So once air begins to flow out, it becomes decrease. So balloon at a rate, that rate we can subtract. So 0.8 pi r. So next, the balloon remains a sphere at all times. So we have to show this dr over dt. So remember that we need chain rule also here to show this part. For that, we must know the volume of sphere as well. Like volume of sphere is v equal 4 over 3 pi r cubed. So we will take the derivative of volume with respect to r. That gives me dv over dr is equal 4 over 3, as we are looking with respect to r. So bring down the power, subtract 1 from the power. That means r square. Cancel 3 and 3. So it is 4 pi r square. And we will apply the chain rule as well. That gives me dr over dt. For that, I must have dr over dv multiply dv over dt. So now we can apply this. Remember, this is dr over dt, dr over dv. So this is dv over dr. So once you change into reciprocal, this becomes 1 over 4 pi r squared multiply dv over dt. We know it is 40 pi minus 0.8 pi r. And once you multiply, it gives. So next step, we will multiply 1 over 4 pi r square inside. So it gives me 40 pi over 4 pi r squared. This gives me cancel pi and pi. So 10 over r square. We can cancel 4 as well. Pi with pi, r with r. So 1 over 5 r. Or one more step, we can say that dr over dt is equal to LCM is 5r squared. This gives me 50 minus r, which is required form of dr over dt. So in B part, find the quotient and remainder when 5r square is divided by 50 minus r. So we will check. 50 minus r, we can say that minus r plus 50. So minus r plus 50. My dividend is 5r squared. So we can take minus 5r, and once you multiply minus 5r with r, it gives me minus 5r squared, and then with 50, so 250, which is equal minus 250r. After subtraction, we will change. First, we change the symbols. Like if it is minus, write plus, plus. So cancel. It gives me 250r. And now we will continue with the help of minus r plus 50. So minus 250 will work for us. That means once you multiply minus 250 with r, it gives me 250r. And then minus 250 multiplied by 50, it is equal minus 12,500. And here we have plus sign, so change the symbols. Plus cancelled, so we have 12,500. And remember, this is our remainder, and this is our quotient. It means required quotient is equal minus 5r minus 250, and our remainder is 12,500. This is the required B part of this. Next, we have C part, solve the differential equation. In part A, it was dr over dt 50 minus r over 5r square. That was the differential equation part A, obtaining an expression for t in terms of r. So the first step is to like separate this differential equation. 50. If we take this one other side, it will change into reciprocal, like 5r square over 50 minus r dr, and here we have dt. Nothing, that means 1. So this is the separate situation or position of this differential equation. Once it is separate, we can apply integration, but remember that this is improper. So like uh, basically we have this rule to change, like we already solved in B part 5r square over 50 minus r. That gives us like p of x over d of x is equal quotient plus r of x over d of x. That means I'm gonna write in this form so that we can apply integration, uh, like concept of partial fraction. So for that, we already know the answer of this part from the previous part, which is equal minus, the quotient is 5r. It was 5r minus 250 plus the remainder is 12,500 over our divisor was what, 50 minus r, and here we have dr, and right hand side is integration 1 dt. Now we can apply the integration, so it is 5r square over 2 minus 250r. Then we have 12,500. And remember, this we can write in log form, which is equal log of, remember the derivative of 50 minus r is minus, so that's why I bring here minus. It means we can write straight away log of 50 minus r, and then plus is equal to t plus constant of integration. So we will find t. If you check carefully the previous part, we have given when t is equal to 0, r is equal to 0, then we can find c easily, like 0 minus 0 minus 12,500 log of 50 is equal to t is also 0. That means c is equal to minus 12,500 log of 50. We can find t as well, like right hand side we have t. So t, as we are looking this expression t in terms of r, so t is equal to minus 5r square over 2 minus 250 r minus 12,500 log of 50 minus r, and if you take this c value other side, it becomes plus 12,500 log of 50. I will use the answer of c part. It was minus 5 over 2 r squared minus 250 minus 12,500 log of 50 minus r plus 12,500 log of 50. So now we are looking the value of t when the radius of the balloon is 12, means when r equal 12. So it gives me minus 5 over 2, or 12 square gives me 144, and then 250. The value of r is 12 minus 12,500 log of 50 minus 12 plus 12,500 log of 50. So here we can cancel with 72. So 72 multiplied by 5 gives me 360. 250 multiplied by 12 is it is equal 3000 minus this. If you solve in the calculator, it gives you 45,469.827, and this would be equal to, if we check in the calculator, it gives me 48,900.29, and at the end t equals 70 point. If we solve all this, so it gives us 70.5. I hope so. Next question, the variable y and theta satisfy the differential equation. So again, first of all, we will separate the differential equation and then apply integration to find the value of c by applying y is equal to 0 and theta is equal to pi over 4. So we start with 1 plus y, 1 plus cos 2 theta dy over d theta is equal to e power 3 y. So of course with the 1 plus y we will write dy, and we will take e power 3y from right to left. It gives me 1 plus y over e power 3y dy is equal to 1 over 1 plus cos 2 theta d theta. So it's now separate, so we can apply integration, or we can do one more step like 1 plus y, take this to e power 3y up, so it becomes negative. And the right hand side, remember that cos 2 theta is basically equal, there are different formula of cos 2 theta, so here I'm applying 2 cos square theta minus 1, that one. So this gives me 1 over 1 plus 2 cos square theta minus 1 d theta. So next step, we can say that integration 1 over 1 plus 2 cos square theta minus 1 cancel, plus 1 minus 1. So this is equal 1 over 2, and cos square theta is basically secant square theta d theta. So integration of secant square theta is easy to write tan theta, but we will see later because the far left hand side we will apply integration by parts. So for that I will consider 1 plus y as u. So u is equal to 1 plus y, then du over dy is equal to 1, or du is equal to dy. And the second function of integration dv, I will consider integration e power minus 3y dy, so which is equal e power exponential. When you apply the integration it will remain same, so in the power we have, so this gives us e power 3 minus 3y over minus 3, and now we will replace back. And remember that integration by parts, we have this formula that will help us. U dv is equal to uv minus integration v du. So I will replace the value of u and v, but better we apply here the left hand side. So it is 1 plus y, and we have v, which is e power minus 3y over minus 3 minus integration. We have the v function is e power minus 3y over minus 3 dy, because du equal dy, so dy. And right hand side we have, as I said before, the integration of secant square theta is tan theta and plus constant of integration. So we will simplify a little bit more further, then we will check at these points. So here we can say that minus 1 by 3 1 plus y e power minus 3y, and this minus minus plus, but remember, okay, we can write plus and bring outside this 1 over 3. So integration of e power minus 3y is again minus 3y over minus 3 is equal to 1 over 2 tan theta plus c. So next step, minus 1 over 3 plus bracket open 1 plus y e power minus 3y, and here minus plus minus, so 1 over 9. 1 over 9 e power minus 3y is equal to 1 over 2 tan theta plus constant. Now we will check constant at y is equal to 0, means at y is equal to 0 and theta is equal to pi by 4. This gives me what? So minus 1 by 3, 1 plus y is 0 power e power y is 0, so it becomes 0. So that means minus 1 over 9 e power 0 is equal to, remember, 10 45. Basically, if pi over 4 represent 45, so 10 45 we can check in calculator as well. It gives us, and here we have minus 1 by 3, and because e power 0 is 1, so minus 1 over 9, and right hand side 1 over 2 into 1, because 10 45 is 1, so we can bring left hand side, it becomes minus 1 by 2. And if you check all this in the calculator, you will get answer c is equal to minus 17 over 18. So replace back in the above question. So it is 1 over 3 1 plus y e power minus 3y minus 1 over 9 e power minus 3y is equal to 1 over 2 tan theta. The value of c is minus 17 over 18. And next, solve this differential equation to find exact value of tan theta. So when y is equal to 1. So we will check at y is equal to 1. It gives us what? When y is equal to 1, it gives me minus 1 over 3, 1 plus 1. It is 2 e power minus 3, because y value is 1, and minus 1 by 9 e power minus 3, and equal 1 over 2 tan theta minus 17 over 18. And then later on it is equal 2 minus 2 over 3e power cubed minus 1 over 9e power cubed is equal to 1 over 2 tan theta minus 17 over 18. As we are looking tan theta, so 1 by 2 tan theta is equal to, if we take 17 over 18 other side, so 17 over 18 would be plus, and here you can take 1 over e cube common, so minus 2 over 3 minus 1 over 9 gives me minus 7 over 9, bracket open, 1 over e cubed, and lastly you can say that tan theta is equal to 1 over 9, bracket open, 17 minus 14 e power minus 3. So lastly, we will solve this question, a differential equation, which is the variable are given x and y, and the differential equation is x squared dy over dx plus y squared plus y is equal to 0. And we will check these values at x is equal to 1, y is equal to 1 to find the constant, and then later on we'll find the expression y in terms of x. So we'll start with x squared dy over dx plus y square plus y is equal to 0. We'll take y square plus y other side, then it becomes x square dy over dx is equal to minus y square plus y. Then with y we can write 1 over y square plus y dy is equal to minus 1 over x square dx, or we can say that y bracket open y plus 1 dy. Now it is in separate, so we can apply integration as well, but remember that here we can use partial fraction as well. That means 1 over y bracket open y plus 1, basically both are linear, so we can suppose to say that two constant a over y plus b over y plus 1, that means 1 is equal to a into y plus 1 by, and we'll check at y is equal to 0, so a into 1, b becomes 0, that means a is equal to 1, and next value we can check at y is equal to minus 1, so 1 is equal to a becomes 0, so b into minus 1, that means b is equal to minus 1. So required partial fraction is 1 over y minus uh, 1 over y plus 1. That means integration of 1 over y into y plus 1 becomes 1 over y minus 1 over y plus 1 dy is equal to integration x power minus 2 dx. After this, we will find out the integration of 1 over y with respect to y, which is log of y minus log of y plus 1 is equal to minus x power minus 2 plus 1 gives us minus 1 over minus 1 plus constant of integration. So it is log of y, as there is a minus sign between two logs, so we can write in division form. So y plus 1, which is equal, this minus minus cancel, so we have 1 over x plus c. Now we can find c at x is equal to 1 and y is equal to 1. So log of 1 over 2, 1 plus 1 2, so and x is 1, so basically this is log 1 minus log 2, 1 plus c. So it means c is equal to log 1 0, so we have minus 1 minus log 2, and then we will replace back. Log of y over y plus 1 is equal to 1 over x minus 1 minus log 2. After this, we will write this differential equation for y in terms of x. So we will bring together log as well. This is log 2. So if you bring it left, it becomes plus. That means we can write log 2y over y plus 1 is equal to 1 over x minus 1 gives us 1 minus x over x. So once you remove the log, we can bring exponential right hand side. So it is 2y over y plus 1 is equal to e power 1 minus x over x. And next step, we can change into reciprocal as well. Y plus 1 over 2y is equal to this we can change into minus. So minus bracket open 1 minus x over x. And next step we can say that y plus 1 over y is equal to 2e power minus. We can say that x minus 1 over x. And next step, this left hand side is basically 1 plus 1 over y is equal to 2e power x minus 1 over x. And as we are looking y, so 1 over y is equal to 2e power x minus 1 over x minus 1. And then later on, as we are looking y, so we can change it to reciprocal. So this becomes y is equal to 1 over 2e power x minus 1 over x minus 1. So our is our required answer. Thank you for watching.